Keep going. 4, 5. 4 left. 4, 5. A pumpkin is thrown off the top of the building. First of all, don't do this. My favorite band in the world is conveniently called Pumpkin. Okay, and they let pumpkins thrown at them a lot. You wish you could really theater if you were to do that. Throw a pumpkin to the band. A pumpkin is thrown off the top of the building. I'm not going to get into throwing things at people. D of t equals negative 4.9 t squared plus 11t plus 50. What is the speed of the pumpkin as it hits the ground? We did one almost just like last one, like a week ago. I'm going to give you one hint before we start. D of t is position. Let me just rephrase this because we got on the issue here. D is equal to distance in meters. T is equal to time in seconds. Okay, so if last time we were talking about like kilometers per year and things like that, remember we did that question before? I'm just throwing something. Forget it. Yeah, that's what they're like. Thank you. Distance over time. Okay. In physics, how do you get velocity? What's velocity? There's a million ways. What's the simplest definition of velocity? Velocity is distance over time. Okay. So velocity is going to equal distance over time. In calculus, velocity is going to equal the limit as delta t approaches 0. FL. Sorry, let's try again. T of t. There's your speed formula. There's your speed equation right there. Okay? Now we didn't talk about this one before. It's the same equation. There's only one equation in this whole course. Learn that. There's only one equation in this entire course. That's it. Not this entire course. This entire chapter. Right? Let's say, Mr. Sadler, I don't like deltas, and I want to call them h as soon as you stop talking. Call it t plus h minus d of t. It's the same equation, right? Change in distance over change of time. Can someone be brave and guess what the acceleration equation would equal? Which one? The one we're going to use in calculus. What would instantaneous acceleration be? What is acceleration? Okay, I'm going to call it delta v over delta t is what I'm going to call it. Right? Change in velocity over change in time. So the instantaneous way to change of velocity is acceleration. All right, take a second right now and do this question. Well, you don't need one. For this one here, why do I need the time? Why do I need the time? Yeah, okay, well, I need to find the speed at a certain time, like that's what I need, right? So I'm going to solve here 0 equals 4.9 t squared plus 11t plus 50. I'm going to write on the board the plot formula. I'm going to say t equals 4.508 ... Right? Now, I trust that all of you use a quadratic formula. Okay, that's not too much to ask. Yes? I'm not going to be mainly use a quadratic formula tomorrow during this course, so don't think you don't use it. You may need to ask it. Okay, let's do the calculus part. We're up to. I think up to you for the calculus part. Also, the first part of it is going to be the limit of delta t approaches 0, d of t plus delta t minus d of t over delta t. Okay, Matt, can you start the numbers in front of me, please? Yeah, what's an N?
Okay, would it be negative 4.9 t plus h squared, or t plus delta t squared, plus 11 t plus delta t plus 50 minus negative 4.9 t squared plus 11t plus 50.
Yeah.
Over h. Over delta t.
Yeah. And if you want to use difference, if you want to use different h instead of delta t's, that's fine. All right, what goes next? Just put it. Yes.
And expand it.
Okay.
So I kind of took it,
Yeah.
the 4.9 and expanded this.
Yeah. On step there.
Yeah. So it turns into negative 4.9 t squared.
Yeah.
Subtract 9.8 t delta t.
Yeah.
Subtract 4.9 delta t squared plus 11t plus 11 delta t plus 50. And then I also distributed the negative brackets plus 4.9 t squared, subtract 11 t, subtract 50.
Yeah, and that, perfect. And that's the sort of the calculator that would also, and then that's fine. She did that all in step perfect. You guys are all highly intelligent individuals, so that was that today yet. Okay, so I'm expecting to go from here to here without too much confusion. Okay. Patrick, what do we do now? Cancel stuff there, okay? Always remember, and this is, everything here is going to cancel, right? Always, like it should happen, at least in this chapter 1, okay? So, 4.9 t squared cancels with negative 4.9 t squared. Negative 11t, cross with 11t. Negative 50, cross with 50. And we should not put the limit of delta t approaches 0. Negative 9.8 t delta t minus 4.9 delta t delta t minus 4.9 delta t squared plus 11 delta t all over delta t equals limit delta t approaches 0, negative 9.8 t minus 4.9 delta t. So we get d prime t equal to negative 9.8 t plus 11. Okay, now I'm going to slow down here because I'm getting too worked up. Okay, this one should be a standard derivative, right? This one should be relatively good. Okay. And no one's asked me this yet. But I'm going to tell you right now. You ever wondered in grade 10 and 11 why we always use 4.9? So you ever know that? What's the thing acceleration? Exactly, right? When you take the derivative of the position, it turns to the speed is negative 9.8. When you take the derivative of that, you get over negative 9.8 meter acceleration, right? So that's what it all comes down. And that's the acceleration. Sure. Okay, how are we going? So good? How many finish this out? Oh, that was great. Great. 4.508. So to finish it out, it's just going to be d prime 4.508 equals negative 9.8, 4.508 plus 11. I got a speed of negative 33.1 approximately. Therefore, the speed of the function is negative 33.1 meters per second. All right, can say 33.1 meters per second down. Now that is cool. You may not think that's cool, but that's cool. I give you the equation that's going to be, you can find the speed at any point. Okay, that is cool. So, it is cool. It's cool. Just, this is first year physics when they're not before. Every university is all derivatives, it's all first year physics is. So say I hate calculus, which you wouldn't, but I love science. First year science. And I thought let's go with science, and I had fathers before, so Mr. Craig is this one. I love you, Mr. Craig, you're a good person.